Welcome to Module 2. Let us begin with one of the most pressing challenges of our time: energy management. Buildings consume a large share of global energy, often more than 30%. Heating, cooling, lighting, and appliances drive this demand. Engineers must design services that are energy efficient without compromising comfort. Solutions include using LED lighting, energy-efficient HVAC systems, high-performance insulation, and smart controls. Heat recovery systems can capture energy from exhaust air, while variable speed drives optimize fan and pump efficiency. Sustainable engineering services are not only environmentally responsible but also economically beneficial, reducing operating costs. Lecture 2: Renewable Integration. Alongside efficiency, renewable energy is transforming engineering services. Solar panels provide electricity, while solar thermal systems heat water. In some locations, wind turbines and geothermal energy supply power and heating. Buildings can even become net zero energy, producing as much energy as they consume annually. Engineers must integrate renewable sources into traditional systems, ensuring stability, safety, and affordability. Lecture 3: Smart Buildings and Automation. The future of engineering services lies in smart buildings. Through the Internet of Things, sensors and controllers can monitor and adjust systems in real time. Smart HVAC systems respond to occupancy, smart lighting adjusts to daylight levels, and smart security integrates cameras with automated alerts. Building management systems allow centralized monitoring of all services, reducing energy waste and improving safety. Automation also improves comfort. Imagine a building that adjusts temperature, lighting, and ventilation automatically to suit your needs. Lecture 4: Advanced HVAC and Indoor Environmental Quality. Indoor environmental quality goes beyond temperature. It includes humidity, air purity, noise levels, and even access to natural daylight. Advanced HVAC systems use filtration, UV sterilization, and humidity control to maintain healthy air. This is especially important in hospitals, where air must be sterile, or in laboratories, where contaminants must be strictly controlled. Engineers now design for both comfort and health, recognizing that indoor environments influence productivity, mood, and long-term well-being. Lecture 5: Water Management. Water is another vital resource. Engineering services must not only supply water but also conserve and recycle it. Technologies include low-flow fixtures, rainwater harvesting, and greywater recycling for irrigation or toilet flushing. In some systems, wastewater is treated on-site for reuse. Water management is increasingly important as global water scarcity grows. Engineers have a responsibility to design sustainable systems that protect this critical resource. Lecture 6: Waste Management and Urban Infrastructure. Beyond buildings, engineering services extend to urban systems. Waste collection, treatment, and recycling are essential to public health and environmental protection. Modern cities are adopting smart waste systems that monitor bin levels and optimize collection routes. Recycling plants and waste-to-energy facilities turn waste into resources. These services illustrate how engineering connects not just to buildings but to entire communities. Lecture 7: Transportation and Mobility Services. In large complexes such as airports, shopping malls, and high-rise buildings, transportation services are crucial. Elevators, escalators, automated walkways, and parking systems are all part of engineering services. Designers must consider capacity, safety, accessibility, and energy efficiency. For example, regenerative elevators can generate electricity as they move downward, feeding it back into the building's grid. Lecture 8: Emergency Engineering Services. Every building must prepare for emergencies. Beyond fire protection, this includes backup power systems, emergency lighting, communication networks, and disaster resilience. Hospitals require uninterrupted power, often provided by generators. Critical facilities such as data centers use redundant systems to ensure operations never fail. Engineering services play a central role in community resilience, ensuring that buildings remain safe and functional during crisis. Lecture 9: Future Trends in Engineering Services. Looking ahead, engineering services are moving towards sustainability, digitization, and resilience. Green building certifications such as LEED and BREEAM set benchmarks for environmental performance. Smart technologies allow buildings to adapt and learn from user behavior. Cities are adopting integrated systems, sometimes called smart cities, to optimize energy, transport, and waste management at scale. Engineers must also embrace new tools such as digital twins, which are virtual models of buildings used for simulation, monitoring, and optimization. Lecture 10: Skills for Engineers. Finally, successful delivery of engineering services depends on people. Engineers must have not only technical knowledge but also skills in teamwork, communication, and interdisciplinary collaboration. Projects often bring together architects, mechanical engineers, electrical specialists, safety experts, and facility managers. Collaboration ensures that systems are not only technically sound but also aligned with human needs and environmental goals. Engineers must also be able to carry out field investigations, measuring parameters such as temperature, airflow, and energy use, then analyzing results to propose improvements. Summary of Module 2. In Module 2, we explored how engineering services are applied in practice and where they are heading in the future. We covered energy efficiency, renewable integration, smart buildings, advanced HVAC, water and waste management, transportation, emergency services, and emerging trends. The future of engineering services is one of sustainability, technology, and responsibility. Engineers are called not only to design systems that work but also to ensure that they are safe, efficient, and environmentally sound. Course conclusion. This course has introduced you to the world of engineering services. In Module 1, we covered the fundamentals: electrical, mechanical, plumbing, fire protection, communication, safety, and regulations. In Module 2, we examine advanced applications, sustainability, smart technologies, and future directions. By the end of this course, you should be able to recognize the different categories of engineering services and their importance. Understand how these systems interact to create safe and comfortable environments. Appreciate the role of sustainability and innovation in shaping the future of engineering services. Analyze and evaluate services in terms of safety, health, energy, and environmental performance. Engineering services are more than technical systems, they are the foundation of modern life, making our buildings and cities safe, comfortable, and sustainable.